Hey guys, today we're going to solve LeetCode number 1022, sum of root to leaf binary numbers. So we're given a binary tree with only 0 and 1 values, and we need to return the sum of all of the binary numbers represented by the root to leaf paths. So for example, in this example here, we have the first path 100, then 101, 110, and 111. And we convert those to decimal and we sum them. Okay, so the way we're going to do this is we're going to use a depth-first traversal of the tree, because remember that a depth-first traversal is like tendrils going out from the root, while a breadth-first traversal is kind of like a liquid spreading on a surface. So to get the paths, it sounds more reasonable to use tendrils going out from the root. Okay, so instead of doing anything with the string concatenations and then converting them from a string of binary digits to a number, instead we're going to use the very common algorithm to convert a binary number to a decimal number. So the algorithm is just for every new digit that you meet, you multiply the current value that you're storing by 2, and then you add the new digit, and you keep doing that until you get to a leaf. Okay, so that's going to be our recursive function. So what's going to happen is we're going to have a sum variable, which we initialize at 0, and later on we're going to return this sum variable. So this is going to be our return value. And then we're going to use a depth-first traversal of the tree. So this is going to be our recursive function, which goes through all of the root to leaf paths in our binary tree. And so now we just need to implement this function. And this function, by the way, it's also going to update this sum variable up here. Okay, so here's the implementation of our depth-first traversal of the tree. So first of all, we have two parameters. The first parameter is the node that we are currently visiting. And by default, we use the root, so the root of our tree. And the second parameter is the current sum, is the current binary number represented by our path here, which I call current sum. And I initialize it with 0. So the default value of this parameter is 0. Okay, now we need the base case for our recursion, and the base case is if we have no node, if we're visiting a node which is null, and in that case we just return. But what if the node is not null, so we are on a valid node? In that case, we do the standard algorithm for the conversion from a binary number to a decimal number, which is multiplying the current sum by 2 and adding the new digit to the current sum, just like that. Okay, and now we need to check if we are on a leaf value. So if we are on a leaf node, what we need to do is to add the current sum of the path from the root to our current leaf to the sum variable, which we are later on going to return. So how to check if the current node is a leaf? We just check if it doesn't have a left child and it doesn't have a right child. So if it doesn't have left child and it doesn't have right child, then we are on a leaf. And so we need to add to the sum the current sum, the current path. Okay, and now also we need to return straight away because we don't want to do anything else. So this is a shorthand to do this operation and also to return so that we don't move on in the function. Okay, now we just do the recursion. So we call the same function with the updated parameters on the left child and on the right child. So that's it. I'm going to show you that it works, and this is a optimal solution because it just goes through all of the nodes once, which is obviously required. And the depth-first search is a optimal way of traversing the tree. It doesn't use a lot of extra memory. It's just O of n extra memory in the worst case, which is always needed for traversing trees. So that's it for today. Thank you for watching, and bye.